Here's another question that's quite similar, and we'll work through this one. In this case, there's no like 90-degree angle. It's just, you can see that they're tied, two masses are hanging from a pulley. So think about what's going to happen if I let go of these pulleys. The 25-kilogram mass is heavier, so it's going to accelerate downward, while the 10-kilogram mass will accelerate upward. Right? So this will be the direction of the acceleration. So sticking with our convention, we're going to make the down, for this block, we're going to make down positive, but for this block, we're going to make up positive. So that might seem a little tricky, but I think follow through the problem with me, and I think it'll make sense as we go through it. So let's look at the forces acting on these. So you've got force of gravity, Fg, on the 25-kilogram block here. And then you've also got Fg on the 10-kilogram block here. And then you've got these tensions up, T and T. Now I'm going to call these tension, and know that since this rope is an ideal rope, these two forces are action-reaction, and they're equal in magnitude and opposite in direction. You can see they're opposite in direction. You see how the tension is positive for the 10-kilogram mass, but it's pointed in the negative direction for the 25-kilogram mass. So we can set it up exactly like we did before, where we'll look at the 25-kilogram free body diagram, and we'll see that the F net equals the sum of the forces, which equals ma. Now in this free body diagram, the sum of the forces, I've got Fg on the 25 kilogram is positive, minus T, which is negative, and that equals to ma, and subbing in stuff that we know. So Fg of 25 is just going to be 25G minus T equals 25A, right? And again, we're down to what we don't know. We've got tension, we've got acceleration as my two variables. So let's look at the 10 kilogram free body diagram, set up my F net statement. Okay, so now it's the same idea, but look, the sign convention is different. So it's T minus Fg on the 10 equals ma. So T minus, 10G equals 10A. And just if this is confusing, why T is positive here and negative there, I mean, the reason is because what we're trying to do is treat a problem that's kind of in two dimensions, treat it like a one-dimensional problem. We're trying to make it so that the direction it's accelerating is the positive direction. So in the case for the 25 kilogram block, it's accelerating in the direction of gravity, whereas for the 10 kilogram block, it's accelerating in the direction of the tension. So that's why we have these two. So here are our two equations. We have the 25, this one, and we have this one. So now we solve these two equations simultaneously. Okay, so we can start by rearranging this equation so that it's T equals, and it becomes 10G plus 10A. And we sub it into this equation. So when we do that, we get 25G minus, and now we have 10G minus 10A. I distributed that negative sign, and that equals 25A. So then we're trying to find A, so let's do it that way. We get, we have 15, we end up with 35A equals 15G. So A equals 10 over 35G. And then putting that into our calculator, we get 9.8. We get 2.8. So the acceleration is 2.8 meters per second squared. And that's the acceleration. Now, What did the question actually ask for? Determine the acceleration of the mass as shown. So that's our answer. If we were asked to solve for the tension, we would just go back and plug that in over there. But that's not what it's asking us for. Another way to do this, if we wanted to kind of look at this from the alternate way, remember we can always group things as a system. And now what you have to kind of think about this is two masses, so it's like 25 and 10 kilograms. Now, the thing that's interesting is that the different forces of gravity are kind of operating in opposite directions. So if you take the direction of acceleration to be positive, let's just say this would be the force of gravity on the 25 kilogram, and this would be the force of gravity on the 10. The reason I have them going opposite like that is just you can see that in this diagram, the force of gravity here, the force of gravity on the 25 is in the positive direction, whereas the force of gravity for the 10 is according to this, because the acceleration up is positive, so this is actually negative for this particular force. So they work against each other, and then when we do that, we end up with the same equation, and you'll find the same acceleration. Just solving this way, we would end up with F net equals the sum of the forces, which equals ma. So the sum of the forces is just going to be let's just put in the numbers, 10g minus 25g equals, and then the combined mass for this m, it's 35a. And you can see already that's exactly what we got before. Oh, it's not, because I made a mistake. All right, hopefully you watch this video through and realize that I just made a mistake. It is not 10g here. It should have been 15g. Good thing I checked myself. See, that's the one good thing about checking your work. You can see mistakes that you made. So this is actually supposed to be 15g, because 25g minus 10g is 15g. So this is going to also be 15 divided by 35. So 15 divided by 35 equals times 9.8. So actually we get 4.2. 4.2 is the answer. Acceleration is 4.2 meters per second squared. And if I did it here, I get the same thing. And actually what I should have done was, this should have been backwards. Like this would be minus, because if I take up to be positive, if I take the direction of acceleration to be positive, right, and this to be negative, that means that a 10g would be negative, and then the 25g would be positive. So anyways, I can solve this out and I would still get 4.2 meters per second squared. Glad I checked it.